Hi scholars, Mrs. Majors from here in high school. Today we are doing skill 17, simplified trig expression. So today's lesson is going to be very related to skill 16, the trig identity that we learned. So what is in our toolbox for trig identity? All I'm going to do is kind of just talk about what we learned last class, okay? So we know that, what do we know? A lot of things, right? Yeah. Okay. Well, one of the biggest things we learned from last class was this trig identity, that is cosine squared theta plus sine squared theta is equal to 1. Remember that? Cosine squared plus sine squared theta is equal to 1. I mean, really, that's the everything you should know about last lesson. The most important thing. We also learned about two more trig identity that are important as well, and those were 1 plus tangent square theta is equal to 1, and 1 plus cotangent square theta is equal to cosecant square theta. Okay, so we're going to use those three to simplify all the 6 expressions that you see below. So let's look at question A. Sine squared theta times cotangent squared theta. So here's what we're going to do. If you see any of the trig ratios, so for example, if I see cosine plus sine squared, I'm going to put 1 in, and vice versa. Use that. After that, you're going to rewrite everything in terms of sine and cosine and simplify it. So I look at this one. I don't really see anything I can use, so I'm just going to go ahead and write everything in terms of sine and cosine. Okay, sine squared is sine squared theta. What about cotangent squared theta? How would I write in terms of sine and cosine? Cotangent is cosine over sine. Remember that? And everything is being squared. So this becomes cosine squared theta times cosine squared theta over sine squared theta. Right? Because when you square the trigonometric expression, that square goes in the middle. Anything I can do? Yeah, you can simplify that sine theta, and we're just left with cosine squared theta. I think that's it. Cool? Alright, now B, let's see, I can't really use any of the trig identities since none of them has square in it. That's another way you can kind of identify it. So let's go ahead and rewrite everything in terms of sine and cosine. So cosine theta times tangent is what? Sine theta over cosine theta plus, what about cotangent? Cosine theta over sine theta. Oh, that looks hard, isn't it? It's okay, it's not that hard. Alright, two ways you can do it. You can distribute it, or you can simplify what's inside of the parentheses and then multiply cosine theta later. It really does not matter. So that being said, what do you guys want to do? Let's just simplify inside of the parentheses, okay? So cosine. Alright, kind of got caught up. So what I was saying is that cosine of theta, and you look at inside of the parentheses, and you're adding to fraction. So I need common denominator. So what will that be? My common denominator will be the sine theta times cosine of theta. So for the first one, I'm multiplying sine theta top and the bottom. And to the second one, I'm multiplying cosine theta top and the bottom. Then see what happens. Both fractions will have a denominator of sine theta, cosine theta. Right? And then my numerator will be that. So now I have a common denominator. I can just quickly add my numerators together, which is sine squared theta plus cosine squared theta over sine theta, cosine theta. Alright, when you get here, I know a lot of you will be like, woo, I'm going to cancel this out. Do not. Okay? Remember, tip number 1 was what? Use trig identity if you can anytime. And I want you to look at right here. Is there any trig identity I can use? Do you see sine squared plus cosine squared over here? Yeah, what's the sine squared plus cosine squared equal to? 1. So instead of this, I'm going to write 1. So I get cosine theta 1 over sine theta, cosine theta. And let's write the reason why that was the case. Because sine squared plus cosine squared theta is equal to 1. Okay, now I can just go make it as a cosine theta over sine theta, cosine theta, boop, boop, 1 over sine theta, or you can just do cosecant theta. Because 1 over sine theta is same as cosecant theta. So that one was a little difficult, wasn't it? But not that much. You just have to remember, simplify as much as possible, and when you see the trig identity here, use that. Alright, let's keep going. Letter C. I don't see any square. I can't use identity. Let's rewrite everything in terms of sine and cosine. Secant is what? 1 over cosine theta. Cosecant is 1 over sine theta. Tangent is what? Sine theta over cosine theta. So I get 1 over cosine theta sine theta minus sine theta over cosine theta. Okay, I'll just multiply those denominators together. Now what? We're adding, subtracting two fractions, so I need a common denominator. So this one denominator is cosine sine, this one is cosine. So the second fraction needs sine theta to multiply top and the bottom, right? So I get 1 over cosine theta sine theta minus sine theta times sine theta, sine square theta over cosine theta sine theta. So I'm going to combine it together. 1 minus sine squared theta. Alright, I'm going to stop. You're probably like, oh, I don't know where to go any more further. Well, let's go back over here. Do you remember one of trig identity was cosine squared plus sine squared is equal to 1? Okay, which I'm going to write it here. Okay, so cosine theta plus sine squared theta is equal to 1. What if I subtract sine squared theta from both sides? Because I can move my terms around it. Let's see what happened. Cosine squared theta is equal to 1 minus sine squared theta. So what is 1 minus sine squared theta equal to? Cosine squared theta. What's 1 minus sine squared equal to? Cosine squared theta. So I'm going to use that identity right there and make a note here because 1 minus sine squared theta is equal to cosine squared theta from the identity. Then what can I do? Cosine is a common factor top and the bottom, so I can cancel the cosine thetas out to get cosine theta over sine theta, which in fact will be what? What's cosine over sine? Cotangent theta. Final answer, cotangent theta. Okay, you kind of see what I'm doing here? Like it's the same thing, right? It's the same thing. This one, cosecant theta minus 1. Look over here. If I were to subtract, so I'm going to write it here, 1 plus cotangent squared theta is equal to cosecant squared theta. So that was one of the trig identity. What if I move that 1 to the other side of the equal sign? Then don't I get cotangent squared theta is equal to cosecant squared theta minus 1? Yeah, so what's cosecant squared theta minus 1? It's just going to be cotangent squared theta. Oh, how easy is that? So you can do that if you know your trig identity, or if you don't know it, that's fine. Just rewrite everything in terms of sine and cosine. So cosecant is 1 over sine squared theta minus 1. So 1 over 1, which I'm going to make it sine squared theta, sine squared theta. It's a lot of algebra, isn't it? Although it's a trigonometry. Theta over sine squared theta. Common denominator, 1 minus sine squared theta over sine squared theta. What's 1 minus sine squared theta? So cosine squared theta. Cosine squared theta over sine squared theta, which is cosine over sine, everything being square, which is cotangent square. So either way, I get the cotangent square. So if you forgot this trig identity, that's fine. You just have to do a little magic to get there. Cool? Alright, now I have 2 more questions. 1 minus cosine square. I'll probably just use my trig identity. Okay, so cosine squared theta plus sine squared theta is equal to 1. What do I want? I want subtract cosine squared theta from both sides, so that I have 1 minus cosine squared on the right side of the equation. Then I get sine squared theta is equal to 1 minus cosine squared theta. So that's going to be my answer. Cool? Alright, this one, secant square theta minus 1. Oh my word, I just realized that I wrote that wrong. Secant square theta. Oops. Okay, so secant square theta minus 1. I'm probably going to use this third trig identity. So I'm going to write it here. I want secant squared minus 1, so minus 1 from both sides. So I get tangent squared theta is equal to secant squared theta minus 1. So answer, tangent squared theta. Let's say you forgot. Can you still do it? Yes. Rewrite everything in terms of sine and cosine. Secant is 1 over cosine minus 1. So 1 is what? Oops. Well, I can't write it. It's going to be cosine squared theta minus divided by cosine squared theta, since I need a common denominator, and then combine my numerators together. What's 1 minus cosine squared? That's a sine squared theta. And what's sine over cosine? That's tangent squared theta. Either way, you get the answer. Cool, isn't it? Alright, so we did all the problems. Thank you. Bye-bye.